Alright, before we move into our next section and start talking about actual programming, there's one last topic I want to mention in I/O, and that is I/O modules. When you buy a lower-end PLC, it typically comes with a few channels of input and a few channels of output, sometimes even both analog and digital. And you can take that PLC and drop it right into a project, load it with a program, and you're ready to go. But when you buy the more sophisticated PLCs, they typically come with no I/O whatsoever, and you have to add on modules in order to receive signals or send signals out. And the modules come in all different shapes and sizes depending on the type of PLC and the manufacturer that is behind it. And there are very general modules that handle simple digital inputs and digital outputs, and there are also some more specialized modules specifically geared to RTD signals, thermocouple signals, high-speed inputs that have to be read at a much higher frequency than a typical module can handle. There are several different kinds of modules, and there are even generic modules that can attach to several different types of PLCs through Ethernet communication protocols and things like that. So there is a world of I/O modules out there, and we're going to be working with a couple and configuring them in the next section. So I figured it was pretty important to introduce you to this concept. But by using modules instead of PLCs having everything all-inclusive, the PLCs are very scalable. If you need a system that only has 20 channels of I/O, you don't have to pay for 300 channels. However, if an existing project needs to add a few devices and you're called out to the retrofit, you don't have to install a brand new PLC. As long as you have room on your DIN rail, you can probably just add one or two more modules and keep everything exactly the way it is. So, all in all, it's a good system.